This is Kalai Agent, coding assistant. On screen you can see a finished run. The agent thought, grepped through the backend file service, read files, and updated its to-do list, all rendered as these collapsible tool cards. The pop-up you're seeing is the changelog for the latest release, covering the new agentic terminal and code execution tools. Scrolling through the completed run, the agent finished a 6-step research checklist, exploring the workspace, reading the clipboard image handling code, the input component, and the chat history service, then summarizing its findings. You can even expand its thinking blocks to see the actual reasoning. Now here's the new feature request. I'm asking Kalai to work like Claude. When you paste a long block of copied text, instead of dumping it all into the chat input, it should save it as a .txt file with a unique name, plan name plus UID, and attach it to the chat for reference, just like it already does with pasted images. Kalai enters plan mode. It spins up a subagent to explore the clipboard image and attachment flow, greps, and reads through input.tsx, the chat view provider, the plan file tool, and the AI service, figuring out exactly where pasted content is handled. Then it writes the implementation plan to a markdown file. Plan mode pauses and waits for my approval. Approve, reject, and exit. I hit approve, and the agent exits plan mode and starts execution. It lays out an 8-step to-do list. Create the pasted text naming utility with tests, add a paste text handler in the chat view provider, update input.tsx with paste detection and a pasted card, add the CSS, render pasted cards in the message timeline, extend the attachment types, update the changelog, and finally run the build and tests. First task in progress. Kalai writes the new utility, pastedtext.ts, with character and line thresholds and a function that generates those unique pasted_place_timestamp_random txt file names. Then it checks the tests folder and writes the Jest test suite. It reads package.json to find the test setup, then fires off a shell command, npx jest on the new test file. And here's the real moment. The tests run, 10 pass, 1 fails. The moderately long multi-line text case returned false when it should have been true. Exit code 1. So now the agent sees the failure, and it'll loop back, fix the threshold logic, and run the tests again, completely on its own. That's the Kalai agent workflow. Plan, approve, execute, test, self-correct. Part 2. And we pick up exactly where the agent hit that failing test. Watch this. Kalai goes straight into the test file with *replace file, finds the failing case, moderately long multi-line text, and fixes the test data, bumping the line length from 50 to 150 characters so it actually crosses the threshold. One replacement, diff shown right in the card. It reruns the exact same Jest command, and this time, green. All 11 tests pass. Exit code 0, done. The agent just debugged and fixed its own test without me touching anything. To-do list updates automatically. Task 1 of 8 is now checked off, and the agent moves to task 2, adding the paste text handler in the chat view provider and enriching the attachments. First it reads chatviewprovider.ts, pulling up the import section, 60 lines of TypeScript, so it knows exactly where to wire in the new utility. Look at the thinking card. It's planning the edit out loud. Import generate pasted text file name, create snippet, and count lines from the pasted text utility. Add it right after the error utils import. Then *replace file makes the change. Red lines out, green lines in, 1 clean replacement. It keeps going, more edits on the provider, reading sections, thinking, patching. Then this thinking card, task 2 done. Next input.tsx. Need modify handle paste, add listener, extend interface, render card. Input.tsx is large. Let's do this carefully. The agent is literally reasoning about its own approach before touching the file. To do updates again, 2 of 8 done. Now on task 3, updating input.tsx with paste detection, the listener, and the pasted card rendering. First edit. It extends the attach file interface, adding source, snippet, and line count fields so pasted text attachments can carry their metadata. Then it pauses and thinks, wait, can the React web view even import from the extensions utils folder? The web view is bundled separately, so it reads the web view's config to check before writing a single bad import. That's careful engineering. A series of read edit think cycles on input.tsx, handle paste, the listener, the card, and then input.tsx done for now. Update to do and next CSS. 3 of 8 complete. Task 4, styling. The thinking card sketches the design first. A 220 pixel chip, monospace snippet, clamped lines, a pasted badge pill, remove button top right. All using VS Code theme colors so it matches any theme. Then append_file writes the full CSS block into input.css. Chip layout, snippet styling, the works. And it rolls straight into the next task, reading message.tsx, planning how to modify render files so those pasted cards show up in the chat timeline. The agent's still mid-run when the clip ends. 8-step plan, executing itself, task by task. That's Kalai. Part 3, Kalai is wrapping up task 5, the message.tsx timeline rendering. You can see it finishing the star replace file edits, then thinking about the pasted text tag styles. Now add message.css styles. Let's inspect message.css for file tag styles. So it greps the style sheet first instead of guessing class names. It reads message.css, appends the new styles, and the thinking card announces. Next task 6. Extend chat attachment and AI service metadata. Read Kalai backend service chat attachment. This is the data layer, making sure the pasted text metadata survives the trip from the UI to the backend. To-do board. 5 of 8 done. Task 6 highlighted. Kalai greps and reads Kalai backend service.ts, patches it with str replace file, then does the same to AI service.ts, preserving the snippet and line count metadata through the whole pipeline. Task 6 done. Next changelog. Now this part 1 love. The agent documents its own work. It reads changelog.md, sees the keep a changelog format, the current version 2.3.1 entry, and writes a brand new release entry. Version 2.3.2, dated today, under added, pasted text attachments. Pasting a large block of plain text into the composer now saves it as a uniquely named txt file and shows it as a pasted attachment card instead of dumping the full content into the input. It even documents the exact detection thresholds, over 500 characters or over 200 characters with more than 5 lines, the file extract upload, and the pasted badge in both the composer and the timeline. It wrote better release notes than most humans. 7 of 8 done. Final task, run the full build and test suite and fix any issues. Kalai fires up the shell, npm test, 10-minute timeout. And here's the real moment of truth. All green. Every test suite passes, background, WebView content, executor, web search, tool cache, and our new pasted text tests. But the agent doesn't stop there. It thinks, test pass. Now run TypeScript build. The extension has an isBuild config. Check package.json scripts. So it greps package.json to find the right build command. Run npm run compile. Shell fires, isBuild runs. Extension built successfully. WebView built successfully. All builds completed. Exit code 0. Done. And here's the kicker. Even after a green build, it keeps going. Look at this thinking card. Build passes. But the compile uses isBuild, not a full type check. Maybe run npxtsc. No emit? Let's try. That's extra diligence nobody asked for. It runs the full TypeScript type. Check. Exit code 0. Done. 0 type errors across the entire extension. So that's the full arc. A feature request in plain English, explored, planned, approved, implemented across 6 files, tested, documented in the changelog, built, and type checked, all autonomously. The 8th and final to-do is being checked off as the clip ends. That's Kalai Agent, shipping its own feature. The final chapter. Right after that green type check, Kalai doesn't just stop and celebrate. It opens one more thinking card and starts auditing its own work. Look at this list. It's reviewing every file it touched for edge cases. Is the fs import using promises? Good. Does prune pasted text dr use fs.stat and fs.onLink correctly? Available. Does path.basename handle /paths on Windows? It literally asks itself that question and reasons it through. Node path.basename handles both separators. I think yes, it handles both. Good. And it keeps going. Input.tsx, message.tsx, AI service, the metadata flow. What happens if a user removes a pasted text chip before sending? The local file remains. That's okay. Prune handles it later. It even considers the React closure issue. Need ensure paste text response case in input.tsx has access to underscore file reference, which is defined later. In useEffect callback, by the time message arrives, function exists. Fine. That's a self-code review in real time. Then it reads tsconfig.json to double-check the web view was covered by the type check. And there it is. The to-do board flips to 8 of 8. Every single item checked off. The utility, the provider handler, input.tsx, the CSS, the timeline cards, the attachment metadata, the changelog, and the full build and test pass. 8 for 8. But Kalai's not quite done. Watch this. A thinking card says, now save project memory about new feature, and it calls update_project_memory. Expanding that card, you can see it writing facts into its own persistent memory. The VS Code extension now converts large plain text clipboard pastes into .txt file attachments. Pasted text files are saved under global storage pasted texts with names like. So next session, the agent will remember this feature exists and how it works. It's documenting for its future self. One last thinking card. Now final response to users summarizing implementation. Mention files changed, how it works, tests/build. Keep concise. Also note no backend changes needed. And then the final message lands. Implemented the pasted text attachment feature for the Kalai versus code extension. The summary explains what it does. Paste over 500 characters or over 200 with more than 5 lines. And instead of dumping into the composer, the text saves as a uniquely named txt file using the same Ghanaian place plus timestamp pattern as the planned files. A pasted card shows the snippet, file name, and line count, and on send, it uploads as a file extract attachment straight into the model's context. Then the files change table, 8 files, from the new pasted text utility and its tests, through the provider, both WebView components, both style sheets, the backend service, AI service, and the changelog. And the verification section, all green checks. npm test. All 105 extension tests pass. npm run compile, extension and WebView build successfully. npx tsc no emit, 0 TypeScript errors. And the closing note, no backend changes were needed. TXT files already flow through the existing file extract pipeline. One request in plain English, and the agent planned it, built it, tested it, reviewed it, documented it, remembered it, and reported it. That's the Kalai agent. The final step, shipping it. I'm back in the workspace, looking at the changelog with that brand new 2.3.2 entry the agent wrote itself. Pasted text attachments, dated today. You can see the old packaged extension sitting in the folder, Kalai Agent 2.3.1.6. That's the old version about to be replaced. First, the version bump. I open package.json, and there's version 2.3.1, and now it flips to 2.3.2, matching the changelog entry the agent created. Version number, changelog, and code all in sync. Down in the terminal, cd into the extension folder, git add.to-stage everything the agent changed, and then the big one, npx vscode/vs package. That's the official VS Code packaging tool. This bundles the whole extension into an installable file. While that runs, I open the extensions panel and search Kalai. There it is, Kalai Agent on the marketplace, 289 installs, currently running version 2.3.1, last updated 18 hours ago. I hit uninstall to clear the old version out of the way. VS Code asks to restart extensions, and we're activating fresh. Back in the terminal, the packaging kicks in. Executing pre-publish script, npm run vscode, pre-publish, which triggers the compile. Building extension, built successfully. Building WebView, built successfully. All builds completed. The exact same green pipeline the agent verified minutes ago, now running as part of the official packaging step. And there it goes. The terminal prints the full file tree being bundled. Jest, docs, media, scripts, src, WebView, and then the line every extension developer loves. Done. Packaged. Kalai Agent 2.3.2.6, 55 files, 3.82 megabytes. And look at the Explorer. Kalai Agent 2.3.2.6 now sits right there above the old 2.3.1. Now to install it. File menu, command palette. Extensions, install from vsix. The file picker opens. I navigate into the extension folder. Select Kalai Agent 2.3.2.6, dated today, 1:53 p.m., and click install. And there it is on the extension page, Kalai Agent, version 2.3.2, last updated 1 second ago. From a feature request typed into my own chat agent, to an agent planned, agent built, agent tested, agent documented release, packaged, and installed in VS Code. Kalai just shipped Kalai. The finale, testing the feature live, in the freshly installed version 2.3.2. You can see the extension page still showing, last updated, 1 second ago, the packaged vsix in the terminal below, and now I open the Kalai Agent chat panel. This is the brand new build, running the code the agent wrote itself. First, I need a long block of text to paste. I flip to package.json, version 2.3.2 confirmed, then to changelog.md, and I start selecting the whole changelog, from the header all the way down through the new 2.3.2 entry. Hundreds of lines, copied to the clipboard. Now the moment of truth. I paste it into the Kalai composer. And there it is. Instead of a wall of text flooding the input, a clean pasted card appears. Pasted _contampo_. The Ghanaian place naming pattern working live, exactly like the planned files. The card shows a snippet of the content, the unique file name, and the little pasted badge. I remove it, paste again, a new card, new unique name. Pasted _cockham 1784642090449 aw.txt. Fresh name every paste, just like Claude. Hover over the card and the tooltip shows the real path. The file saved under the extension's global storage, in the pasted text folder. The composer stays clean. Then I type the question, what is this about? And hit send. The message lands in the timeline with the pasted card attached. 463 lines, tucked neatly behind one chip instead of spamming the chat. Kalai spins up. You can see the status bar ticking, session cost tracking live at the bottom. Hovering the card again confirms it's reading from that save.txt file. The agent is now ingesting the entire changelog through the file extract pipeline the agent itself wired up. And here's the answer. Total cost, 0.9 cents. This is the changelog for the Kalai Agent versus Code extension. It documents the version history, following the keep a changelog format and semantic versioning. The file tracks all notable releases from version 2.0.3 up to version 2.3.2 foot, and it correctly names the newest entry. The most recent entry, version 2.3.2, adds the pasted text attachments feature, which converts large plain text clipboard pastes into .txt file attachments instead of dumping them into the composer input. The agent is describing the feature it built, about the file it just read, through the pipeline it shipped itself. Full circle. Kalai Agent, built by Kalai, tested by Kalai, and now explaining Kalai's own changelog. That's the whole story, end to end.